I'm going to explain you how we will be able to analyze the TGA graph or plot using our Origin Pro lab software. So before that, I think we should discuss what is TGA and DTA and why we material chemists need it. So first of all, I will discuss the details of it. Then I will show you a plot how could you will be insert the data and most necessary part of the analysis followed by. So I'm going to start this. So mostly we are analyzing the materials thermal behavior using these two powerful techniques called thermogravimetric analysis and differential thermal analysis, which actually help us to understand the materials behaviors towards heat. So TGA tracks the changes in mass while DTA detects the thermal events like melting or decomposition together. They give us a complete picture of material's thermal stability and phase transition. Whereas DTA tracks the temperature difference between the sample and the reference which we have loaded. So initially, we can able to extract the analyzed data in the form of TXT. Let me show you. See, this is the file. As you can see, it is opening in the workbook. Okay. So how, and this is the data, you can see that this is the DTA data and this is the TGA data. So how to extract it to Excel so that we can able to easily put it into the Origin Lab software. So first of all, we have to open the Excel. So now I'll go to data, which I have already opened. Then from text, I'll go to my desktop where my file is present. I will select it and import it. Okay. So then I'll do the next. Then I'll separate it by commas. Then I will do the next again and finish it. Now you can do the OK and see all the four things, the time, the temperature, the DTA and TGA data, everything is now get settled in separate columns. So what we will do, we will select from here to here and we will delete it. Okay. Yeah, okay. So now you can see we have four columns. One is of our times, one is of temperature, one is for DTA, and one is for our TGA. So TGA is calculating for the residual mass loss or the percentage mass loss. That's why we are representing it in the unit of milligrams. Okay, and DTA, it is measured in micro volume as it is analyzed as compared to the reference. Okay. Now I will select all. Control C. I will open my Origin Pro Lab software. Now I will click or place my cursor here and paste it. Okay. Let me maximize it and show it to you. Now you can see all the data sets we have in our Excel. Now we have it in the sheet of our software. Okay. Now what we will do? So actually we want to plot temperature versus our DTA and TGA. So we don't need the time, right? So I will delete it. Now you can click here and make it as X. Okay. Now you can see I have one x-axis and two y-axes. And the two y-axes are for DTA and TGA. So now again I will select all, right click on it, then go to plot. Okay, then I will go to y offset waterfall. No, sorry, I will go to two yy's. Okay. So now see, now the graph appears. I know, I hope you can able to see it. No? So one of our y-axis is our DTA and one is our TGA. So after the graphical analysis done, so let me tell you actually what happened in my graph. Okay. As you can see, the graph is plotted from 0 to 1000 degrees centigrade. Let's discuss each temperature range for DTA analysis. So from 0 to 200, you can see a small peak getting down, which can be possible due to the moisture or water loss. So now from 200 to 600, a small exo or endo events takes place over here because there is minor vibrations. At 800 degree, 6 to 800 degree, you can see there is a sharp peak which can be due to the exothermic behavior which shows a phase transition to us. Sorry. So which can show us the phase transition. Okay. Similarly, if we go for the TGA data, you can see the red plot. Okay. At 0 to 200 degrees, there is no mass loss observed. But from 200 to 600 degree, there is a small mass loss observed. But the noticeable mass falls at around 800 degrees. That is the major decomposition was seen here at after 800 degrees. As you can see, from 800 to 1000, maybe we are able to see the mass plateaus, that is the material reaches to thermal equilibrium. Now you can see on the TGA side, the mass percentage are from 58.2 to 56.8, right? So the total mass loss indicates 1.6 milligram, and this indicates that the material is highly thermally stable. So this is for this video. Thank you so much for watching. If you like the video, please keep commenting, share it with your friends who will get the benefits. Hope you like it. Thank you so much.